Hey, what's up? We're talking about dilations today, a very specific type of transformation. Okay, with dilations, it keeps similarity, but it does not maintain congruence. Okay, so dilations are about enlarging or reducing our shapes. Let's take a look at this, what that means. So a dilation is a transformation in which a figure is reduced, which means we're making it smaller, or enlarged, which means we're making it bigger, okay? Using a scale factor, that means multiplication. So when we think dilations, multiplication, that needs to be the connection. Multiplication to make it bigger or smaller. To dilate a figure, multiply the coordinates, right? There it is, multiply the coordinates of each vertex. Vertex are the points, okay? The corner points specifically of a shape, okay, by the scale factor, and we call that scale factor K until we know what it is, okay? So as a rule, what that means is we start with the pre-image point x, y, and then we multiply the coordinates x and y, you multiply it by the scale factor to get the image point, okay? When K is greater than 1, the dilation is an enlargement. When K is greater than 0 and less than 1, the dilation is a reduction. Okay, and so knowing that will help you get a visual real quick when you see something happening like, oh, this was enlarging, so I know that the scale factor is larger than 1. Oh, it got smaller. Okay, so my scale factor has to be less than 1, right? So keeping those things in mind, if I have the rule and I say, hey, it's 2x comma 2y, I know that's an enlargement. So just being able to go back and forth with that. Let's look at this a little bit more. Triangle ABC is dilated with respect to the origin by a scale factor of something to create the image triangle A prime, B prime, C prime. Remember, this is the new shape, okay? That's how we write it. That's prime notation, okay? If I want to know what the scale factor is, I can take a point and its new point and just see what did I multiply to get the new one. Look, this is at y is 2 and now it's at y is 4. 2 times 2 gets me to 4. So this is a scale factor of 2. Okay. I could do the same thing with A. Okay. I know that A is at, and I can do either coordinate. So if I did the x's, A is at 3, A prime is at 6. 3 times 2 gets me to 6. That's how I know my scale factor. Okay. So a scale factor of 2. And we just said this is larger than 1, so I should know that this is going, that's why it's an enlargement, right? And that's what my picture shows. It shows a small pre-image, and then my image is bigger. All right, so we are given our coordinates of the pre-image, and we want to see, well, what are the coordinates of the image that was created? All right, and look, guys, we could go and look at the graph and see what's going on, okay? So I could say, oh, A prime is 6, 2, right? So let's go this way, 6, 2. And then we have B prime over here is at -2, -2. And then C prime is up here, and that's at 0, 4. And now look what's happening. If I do 3 times 2, that gets me 6. If I do 1 times 2, that gets me 2. -1 times 2 gets me -2. -1 times 2, -2. 0 times 2 is 0. 2 times 2 is 4. That's how I know my rule. Okay. All right. So look, algebraic rule describing this dilation. How we write that is we start with our preimage xy, draw the arrow, and we tell ourselves k times the x value. Well, k, we said, is 2. So it's 2x, 2 times my x coordinate, right? 2 times 3, 2 times -1, 2 times 0, comma 2 times y, because we're multiplying everything by 2 so that it stays proportional, okay? And that's how we would look at this algebraically. We're telling ourselves, what do I do to the x and y coordinates to create the new image? All right, let's look at this again. So draw a rectangle WXYZ and its image after a dilation with a scale factor of 1/2. Okay, so scale factor, that's multiplication. We're multiplying by 1/2. This is less than 1, so it should be a reduction. So my shape should get smaller, right? If it doesn't, I might have done it wrong. All right, so here we go. We have the ordered pairs for the pre-image. And our job is to figure out what is going on with the image. Okay, so let's first plot this -2, -2. There's W. And then Y is X is -2, +3. So there's X. Then we have 5, 3. So over 5, up 3. And then we have 5, -2. There's Z. All right, we're just going to connect our dots. And it said it's a rectangle, so it should look like a rectangle. Yay! Okay, so everything's awesome there. Now we're going to draw the image. It says scale factor of 1/2, so we're going to multiply all the coordinates times 1/2. Okay, so 1/2 of -2 is -1. 1/2 of -2 is still -1. Okay, 1/2 of -2 is -1. 1/2 of 3 is 3/2. Okay, and we can use Desmos to do the calculations if you struggle with that. 1/2 of 5 is 5/2. 1/2 of 3 is 3/2. And then 1/2 of 5, hey, we just did that, 5/2. And then 1/2 of -2 is -1. Okay, that's how you use the scale factor to create the dilation. Here we go. Now we're going to plot -1, -1. This is W prime. Then we have -1, 3/2. Okay, so I need to know that 3/2 equals 1.5, right? So I'm going to go up 1.5. So I'm right here. This is X prime. Okay, Y prime is 5/2. Okay, so 5/2 equals 2.5. So I'm going to go 2.5, and then 3/2 we said is 1.5, so I'm right in the middle here. There's Y prime. And then 5/2 and -1 for Z, so 5/2, 2.5. And then down to -1. There's Z prime. Connect the dots. And we have an awesome reduced rectangle. Woohoo! Yay! All right. That's how you do it. Scale factor, multiplication. Dilations is multiplication. All right, so our rule, remember, our rule tells us what we start with and then what we do to create the image, okay? Our image, we multiplied the x by half. We multiply our y by half. There's our rule. And because k is less than 1, that's a reduction. Okay, the scale factor, remember, that's our scale factor. And that's what we're doing with dilations. It's that relationship, knowing that dilations, multiplication, what's the scale factor? What changes? Oh, multiply the x coordinate, multiply the y coordinate. You have to multiply everything because we have to maintain proportionality when we are doing our dilations.